So I say it again, welcome to PyBay. I'm really excited to be here with you. And most importantly, I'm excited to be here to presenting this panel on static typing. As many of you may know, we recently had addition of type hints to Python. This basically enabled developers to build really powerful tools. Static analysis, dynamic type checking, and making IDEs smarter. And developers that have used and embraced this technology, both in industry and in open source, have found huge benefits. Other than obviously like less bugs, they found like faster onboarding for developers joining teams, and in general like better structure on code. Said this, we also had a bit of confusion. Static typing isn't necessarily the best practice yet, and some developers don't really know how to get started. So for this reason, I wanted to bring this panel here today for two main reasons. The first reason is for all of us developers to understand the power, the benefits of static typing, the pros and cons. And most importantly, for the development community to shed light inside the development community to what is missing in static typing, and most importantly, how we can do better. So without further ado, I would love to give a round of applause for our panelists. So probably as a first question today, can you each introduce yourselves and tell the public the best contribution to static typing up till now that you've done? Yeah.
Now with more sound, I'm Jette Zijlstra. I'm a software engineer at Quora down in Mountain View. I think the best contribution maybe I've made to static typing is improvements to named tuples that we have in the typing library. Named tuples in typing now provide you the possibility to add defaults to your named tuples, to add methods, to add docstrings, and some other things.
My name is Ethan Smith. I'm a college student at UC Berkeley. I work on MyPI, and I also have a personal project which generates type information from your running code. So,
my name is Łukasz. I like Python. I like types. I contribute to Python since 2010, I guess. My biggest contribution to typing is creating the repo for typing, I guess. Yeah, like I was there when the original PEP was created, but like I had like the smallest contribution there from all the authors that are listed. Yeah. Anyhow, like yeah, I work for Facebook these days down in Menlo Park.
I'm Andrei Vlasovsky. I'm the lead developer of PyCharm Community Edition. I've been involved in types for Python for quite a while, since 2010, I guess. And my contributions were, I helped reviewing PEP 484 a bit, and I ported the typing module to Python 2.
Hi, I'm Matthias. I work at Google. I work full-time on a type inferencer called PyType, which we use at Google to statically analyze all our sources. And my biggest contribution to static typing, I'm actually kind of excited that we have, the three big type checkers in the panel today. We have MyPI, we have PyCharm, and PyType. And I started a project together with Jukka Litasalo, a project called Typeshed that we all use for maintaining the standard library in a type annotated form, or to maintaining the stubs for the, we're going to speak about stubs later, stubs of the standard library for all type influencers to use.
That's great. So one thing I wanted to say is that this is an open panel. So if anyone wants to ask a question, please raise your hand, and we'll make it pretty interactive. And if you have specific questions, we'll have time for that after, hopefully. Yeah. So the first question I had was related to industry, actually. So many of you come from a medium to large size organization. and have told me that you've adopted static typing within your organization's projects. Can you tell me how hard it was to introduce static typing in your organizations, and the pros and cons, the benefits and difficulties?
Yeah, I can answer that. So at Quora, I was the first user of static types in various projects. The way we started actually was just, I was starting a new project for a new service and decided to use some new exciting parts of Python. So I started using async.io, I started using types. And it actually turned out to be a really good experience. It made the code base easier to understand. It made it a lot easier for me to make changes because I can just run the type checker to make sure that the code is still correct. And since then, we've started moving a little bit towards using types in more parts of the code base, in more new projects. Yeah.
Okay, so at Facebook, we have almost 1/3 of our Python projects already running on Python 3.6. I mean, like in production. So like all of our servers, like literally as we speak, are running Python 3.6. So that was sort of, for me, always like the prerequisite to even talk about types. So the one thing in pip 484 I like the least is like the comment syntax, like, you know, like, yes, let's just use this in Python 2. I don't like it. Okay, whatever. You can live in the past for another 2.5 years, right? Like, that's okay. So yes, like now with enough sort of critical mass, we started adopting types as well. When Instagram moved to Python 3, suddenly they unblocked the feature, and now we're like 15%, maybe 16 at this point, typed functions in the Instagram repository. Facebook is a little behind because it's mostly reliant on all the generated thrift code that we have to talk in between services. Thrift is like, I don't know, the oldest sort of generation of what gRPC is currently, I guess. Yeah, so like I just landed support for typing for this just like 2 days ago. And like the funny story for that was like right away, somebody's like, oh, some tests are now failing, so I need to revert your change. And I'm like, yes, they're failing because you have typed errors there. They were always there, but now like the support for it checks for them. So yeah, it's a challenge at times, but at the same time, like, you know, the reason why I would introduce type information in your code is mostly about like human consumption, is about the fact that like when somebody reads your like API, whatever you're reading, like you're writing, like they want to know like what the, you know, magic elements argument to your function means, right? Like what is it? So this already like pretty much generated a pretty large fan base like for type checking, because people were already putting this information somewhere, right? In comments, maybe in doc strings, in some like magical form that was supposed to sort of parse so that you could have it like in a readable form in Sphinx or whatever else. But that readable form, like, you know, for many of the functions never parsed because people, you know, like misplaced the punctuation or whatnot. So it was always best effort. And now we simply have a place where you can put this information in a standardized form. So people can just focus on reading, oh, this is my function signature, this is what it accepts, and just move on. So like this is for me like the biggest reason why you would have type information. And type checking is mostly useful to make sure this never rots. Right? So the fact that like you can find existing bugs and prevent future ones is nice to have, and obviously we want to do this with MyPI, with PyCharm, with PyType. But the main goal behind this is such that, you know, yeah, Python is almost runnable pseudocode, so people sort of under-documented at times, but we wish they weren't, because some of the duck typing sometimes gets really crazy. So yeah, like this is why, you know, it sort of makes you think about your API. Like what does this thing really need? What does this thing really return?
One question related to that, do you usually use external PyI files for that? Or do you annotate your types inside the Python source code?
Well, so the reason why we waited for Python 3 is so that we didn't have to use those like stub files, which like, you know, people internally like call like the Python header files, which is like, oh no, they're not. So yes, like the annotations live there with the code. So when you grep for things, when you look for the function, when you click over like, you know, in Atom, like, you know, it points you at the function where it was, you know, defined, you actually find the type information there as well.
And in a big organization like Facebook, I imagine there might have been people that were opposed to it, or like were hard to move.
And this is where you would be wrong. And like, so like, I
Glad
guess
to be wrong.
I guess it's like in a different organization, maybe, but Facebook comes, you know, like with this nice internal language that we use to develop the site itself, right? And like one of the biggest features of Hack is that it does have type information there, right? It has async await and it has type annotations that made it so easy for me to, like, you know, evangelize Python 3, because it's like, hey, we're also gonna have async await and typing. So everybody was like, oh yeah, we understand why it's useful, because they already seen the usefulness of this in their dub code, right?
Just for the record, so I also don't like the common syntax in Python 2, but you can use types in Python 2 that way. Also, PyType contains a patch that you can apply to Python 2, and that backports PEP 3107, so you actually get the normal Python 3 typing syntax in Python 2. I know it's horrible, but it works for us.
Yeah, and if I'm incorrect, so how many projects actually run PyType in Google?
So we have now about 500 projects signed on. And to answer your earlier question, so for us it was reasonably simple to switch people over to static typing since we use PyType. And one of the features that sets PyType a little bit apart from the other static analyzers is, from the other type checkers, is that you can run it as a pure static analysis tool. So you can just point it on, you can just point it at normal Python, unannotated Python source, and it will try to find the bugs in that program and try to find the type errors in that program. And that way, you have your foot in the door, and then people see, oh, hey, this tool actually finds errors in my code, and this tool is called PyType. What else can it do? Oh, there's type annotations I could also use, and that way we shift our ways inwards.
And is static typing only beneficial for like some code bases? So for example, I might imagine that bigger code bases is probably more suited simply because it's just easier to get code loss between like contributors. Is there any, probably to rephrase the question, is there any type of project where you would not consider using types?
So I've seen static typing used both for tiny one-off scripts as well as for humongous code bases.
I think for any code base that you're going to maintain, it is useful because months later you might have forgotten what kind of arguments your function is taking, no matter how big your code base is, and then it's going to be useful to have types to tell you what this function is doing. With
PyCharm support, now community support, with PyCharm Community Edition, we have typing out of the box, right? That's correct.
Yeah, that's correct, yeah. And we've been doing type inference for a while. We used to have our own legacy custom syntax in the docstrings. So people started using types with the first version of PyCharm, but we have been always looking for a way to standardize this because we didn't want people to write something just to make PyCharm happy. So by introducing this standard, I think we've moved quite a lot as the community forwards. And answering to a question about the size of the projects where type hints are feasible, I believe for small scripts you don't actually need type hints because at least PyCharm is not only a type checker but a type inference engine. So it can infer lots of types for you if your script just uses the standard library we already have. The stub files in the Typeshed repo for the standard library, so you can benefit from type hints without actually writing them. And it applies to education as well. For example, in schools, it doesn't make sense to teach kids how to write type hints, but it makes a lot of sense for them to use an IDE or a smart editor with a type checker plugged in, so they see their errors earlier. So, yep.
It's a very, very good point on, interesting point on the schools. I wanted to actually follow up on that later. But how can adoption of static typing be made easier? I feel like it's still not like a best practice. So how can we promote it? How can we make onboarding easier for static typing?
I guess we need to just prove the value, right? Like there's still like a lot of people that I talk with, and like when they're really like courageous, they would like talk openly about how they're afraid or like don't like types. If they're not, they just avoid me. Like, okay, fine. But the thing about it is when you actually start using this, like you're gonna see like, hey, it actually makes me think about like the inputs and outputs to my functions. It actually doesn't make my code terribly, ugly. Some people just like give me examples or like, look at how ugly this is, but on average, that doesn't make Python Scala, right? It's okay. It's still readable. That's the entire point. It is a bit verbose because the original intent of the PEP was to use the existing syntax. So there were like no additions to the syntax to make maybe generics a little bit nicer and like optional types maybe a little bit nicer. Because we didn't really know if that's going to be usable at all. So which is why type comments were a thing from the start, to be able to like inform the type checker about types in local variables, right? Because the inferencers can do a lot of things, but when like you start with an empty collection, like with an empty list or whatnot, like the type checker doesn't know like what is supposed to go there. What inferencers will tell you is what actually went there, so they will assume it's okay. But the type checker's role is a bit different, right? It's about to like confront the reality with the expectations. So you have to set the expectations. So we had like ugly type comments for this purpose from day one. But later on, like there was another PEP, right, which introduced actually variable annotations, and now in 3.6 you have proper syntax for this. So it is evolving, and I think like it still is gonna take a release or two to like make this thing easier to adopt. Like there's things that frankly are compromises, and they stem exactly from the fact that we didn't want to change like a lot in Python internals to support this. For example, you have to actually import the uppercase list and uppercase dict, which is confusing to newcomers, right? So this is a very true point that when you start really learning Python, maybe just using typing from day one isn't the best thing that you can do, because like then you're gonna ask questions like, do I instantiate those big lists? Like, what do I do with them, right? So
That's
like
the one PEP I really look forward to,
Yeah.
The one that lets you lowercase the list type annotations.
Yeah, so I guess like yes, I want this part of the typing module to go away, right? Like that's simply a stepping stone, right? So this is something that we're gonna have to improve. I did like a small thing that was it's almost embarrassing to say, right? Because it's a hack, but like Facebookers are really like proud of like the hacky things that they do. So yeah, I'm gonna like share that with you. So what we're using internally for like reviews is Fabricator, right? Like what we're using internally for code editors is like most of the people are either on VI or on Atom with Nuclide. So for them, like having like IDE support for typing was like a tremendous task. Like I would never be able to do it like correctly for a long time, like just not in one person. So what I did is I wrote a very silly Flake8 plugin that runs MyPI, but only for the current file that you have open. So like the inference that it can do like on your program is super limited because that's just this one file. But it turns out that because of the PYI files in Typeshed, like that cover like the third party and the entire standard library, this is already very useful. So like to answer your question about is this useful for small programs, like no, if you're learning Python, but if you already know Python, then yes, because if you're using like a silly, like Flake8 plugin like this, like you're already gonna get like maybe a few type errors there. Like so, that's very immediate feedback, and this is where you see the value.
And for projects that for big projects that cannot afford, let's say smaller companies that cannot afford to actually invest substantial amount of time porting those projects over. Would something like the tool that Ethan built help them? Ethan, you want to?
So the tool I made uses the new PEP 523, which allows you to hook into the Python interpreter and get all of the information the Python interpreter knows. And that includes type information for all of the arguments to function calls you make and the return values. And so from that, you can generate all this type information and collect it, and then generate these stubs, or you can put it into your own code, and you get all of the types that way. And so this will be really useful for very simple types, such as int, string, things like that. It'll probably not catch the more complex cases, but it will form a very good basis for those who want to type their code.
So we have actually also tried this approach, and it's very powerful. We use that to roll out type annotations to YouTube.
Oh, so does PyType support that? Or not?
What Ethan is talking about is that you modify or hook into the Python interpreter in order to record types at runtime. So on your server processes or in your applications, while they're running, you record all the types they see. And that gives you type annotation, type information of your entire program. And then using that, you can put that back into type annotations, and suddenly you have a typed program.
We also have this mode in PyCharm, but we record types when you debug your code. So we put this type collecting code into the debugger. It is quite slow, I should say. So we have disabled it by default, but you can go and enable it. And after that, you can run your code inspection in order to inject these types via quick fixes to your code in PyCharm. And we've seen people doing it. Unfortunately, you cannot infer more abstract types. So you will stick with lists and ints instead of, I don't know, numbers and iterables. But still, it's a good starting point.
Yeah, we also have a question.
So my question is, do these tools actually modify your .py files? Like, do they actually see it running and then modify your Python source so when you look at it next, you'll see type annotations? Or is it giving you the information in some other way?
That's how it works, yes. So, I mean, it's usually a two-step process. You first generate a PYI file, which are the stub files we were talking about earlier. That's like a header file for Python. It just contains the types of a Python source and nothing else. And once you have that, there's an open source project called merge PYI that takes a PY file and a PYI file and then gives you a PY file that contains the types.
Thank you for asking questions. As I said, if anyone has questions, like Fabio, you should ask them.
Sorry, I tried to ask before the question, but anyone saw. So we have three tools. PyType, MyPI, and also PyCharm has its own inference capabilities. And each one is using a different inference engine, right? So each one is inferencing in a different way. And I think right now, the only one that clearly does static analysis like that you can run on your CI or something is MyPI. Because I tried to look on PyType, and for the docs, it looks like that it's only generating the PY files. And about PyCharm, I don't know how to integrate that on the CI. So I'd like to know a bit more about that, if that's a goal for these tools to be used really as a static analysis tools, like a linter, like a more powerful linter that has inference on it. And if it is, how can I use this?
I hear you. Yes, our documentation is horrible. You can totally use PyType as an CI, as a static analysis tool. The easiest way to do so is probably to drop me an email and tell me that you want to do that. Then whatever I'll tell you, I'll also add to the documentation.
What did you just do? Like, you know.
He's being helpful. It's great.
He likes emails. He just said he likes emails.
Ouch. Ouch.
PyCharm also can be run on your CI server. We have the script called inspect.sh in the bin directory of PyCharm. You have to create your inspection profile where you specify which inspections you would like to run on your CI server, like type checker, maybe unresolved attributes inspection, and so on. Then you can run it, and it will generate reports and so on.
I think in general, something you were talking about how there are 3 separate projects. An idea that I've had, which would be that I think could be very useful, is to at some point learn from all of them and try to unify what we've learned into a type system for Python, so that we don't have 3 separate projects, and so your code doesn't have to be tested against 3 separate things, depending on what your library users are using. And I think that could make new users of typing be a lot more interested in using it. So.
Yeah, so I think like the type checker for Python that comes with Python with the batteries included philosophy is on the table. It's super early, and the standard library is where modules go to die, so you cannot really develop a new one on it. Like we tried to do that with async IO, it was painful. We tried to do that with typing, and it is painful. So like for the type checker itself, like now, we have the technology. There's the internet, there's MyPI, which works very well. Like we can use this for now to iterate quickly. And like at some point, probably it is gonna make sense to bundle one with the other, but we're nowhere close to that point yet.
Oh, speaking of the common type inference engine for Python, I should say that there are at least 2 use cases. One is when you run your type checker against your whole code base, like MyPI, for example, and another one when you are editing your code interactively. So in PyCharm, we have to support a different mode of type inference, incremental type inference, which is quite different from what MyPI does. So yeah, maybe there will be 2 engines running in 2 separate modes, but still, yeah.
Okay, so I have a question for the PyCharm developers. PyCharm I've used, and I really like it for the interactive capabilities. But when it comes to trying to integrate it with our CI system, it kind of falls. That we'd like to be able to apply the same tooling that we use when we interactively develop on the build system itself without UI support. So just wondering what you're going to provide, or do you have plans to provide support for command line driven?
Yeah, I was just talking that we have this inspect.sh script, and you can run the same inspections on your CI server, provided that you have your inspection profile configured in PyCharm. So it's definitely possible. We have documentation on it.
What are the performance ramifications of adopting typing over an entire code base? It could be positive, potentially, by hooking into JITs and things like that. It could be negative because there's more things to import at runtime. And I'm just wondering what your experiences are as far as the performance implications of adopting typing.
So far, the performance implications are slightly negative. They're like mostly on startup time, because you do import the typing module. There's more code objects that you store, because there's the annotations are actually preserved at runtime. But it's a minuscule, difference. So, I wouldn't worry about this. If you worry about this, means you're already in hundreds of thousands of lines of code, so you have other problems now. It potentially can improve performance in the future. It was specifically not marked as a goal of the original PEP. The reason for it is that, the current state-of-the-art JITs actually have better knowledge on the, types actually used than you would put there. So, most of the time, the goal of your typing, which is human readable, sort of specification of intent, is going to be slightly different for what you're using, in actual code. What is interesting though is that we already had a piece of technology for years now that is using typing information to make Python much faster. It's called Cython. You should use it. Use it. Cython does exactly this. Like by providing some C-type information, you can do specializations in ahead of time compiling. So this is something that Yuka and like I guess other members of the MyPI team are actually looking into. That would be very interesting to apply this information to know that this is only going to be ever an int, so we can actually make this like bytecode a bit nicer. Yeah, but so far like for the JIT purpose, that's not really super useful. Especially that like we are also internally running something that is gathering types at runtime. Like we hope it's going to be open source because it is actually pretty useful. And the funny thing about it is that it is slowing things down enough that we need to do sampling like every X requests, and that first of all like causes there not to be full information about like types used, but it's just statistically significant. So there's gonna be like some 40% or maybe 50% of types that you are able to cover that way. But funnily enough, like sometimes you have APIs where you specified an optional argument and you never used it. So the suggested runtime type is gonna be, this is none. This is only ever none. Like, so what's the point of the argument? But yeah, that's the thing, like types at runtime are very often different than what your intent was.
So if I'm understanding that there's 3 separate typing engines, should I expect them to agree with each other, or do they ever have disagreements? And then how do you figure out which is the real answer?
Currently, we don't have any common tests, but I would really like to see it coming. I have a pull request on GitHub, and if you are interested in having, I don't know, universal understanding of types for different engines, I would like you to help me implement it.
The good news is that we're all cooperating, and we have the shared project Typeshed that contains the PYI files that we all use. And in a sense, those are tests that we all run. I mean, those are all sources that all our inferencers and checkers need to be able to parse and interpret in roughly the same way. So.
I've been watching TypeScript go through a similar thing at a similar time. And one of the things TypeScript is enabling, like for Angular, is dependency injection. And then I also saw a project on the Python side, one that does dependency injection, another one that is doing like schema validation, taking type hinting information and at runtime doing validation. These other uses beyond just linting of your code, use or abuse?
Yeah, so specifically when we wrote the PEP, we didn't really add anything in terms of runtime type checking there. But like, the Sharia secret, the typing module has always been written in a way where you can actually use the, type information like at runtime, like which is why we preserve the annotations. So if somebody really wants to, they could write a runtime type checker, which I think at some point is going to happen. Like, just a personal opinion on dependency injection, like, don't do it in Python. Like, why would you do it? It's like you can just add another PY file next to it and like, just, it's not like we're Java where we are like a compilation step away. Like, so I've seen like Spring, the framework, having like a version like that you could use in Python, and that was like ugly abuse. It's like the code that actually removed it simplified all the projects I've seen using it before. So I don't know, but the runtime type checking is definitely interesting. The interesting thing about it is like, hey, we could use it during unit tests, right? Like that's like the perfect opportunity to actually like do additional checks, right?
Yeah. So I looked at all of the type checkers on GitHub because I wanted to do an overview, and there are currently 12 dynamic runtime type checkers that conform to PEP 484. There are about 20 more that don't conform, and the 12 that do are at various levels of completeness. But they use sys.setTrace, which can be rather slow. So that can add quite a bit of overhead. So I actually also am looking at making a type checker that uses the frame evaluation API, which should allow type checking to be run much faster on real code. So
I'm curious more about the opportunities you see for either really complex data types, because sometimes people have these that they build up and they're pretty complex, and so they're hard to type check. They're often recursive in some way. And especially as you sort of pass the boundary of what's the static program data for, we're linking off to other languages, we're pulling in large sets of data, and we spend half our life scrubbing that data, so we want to be able to immediately pull it in and say, yeah, some of these types are not like the others. And so what type of opportunities do you see type checking moving into there?
So if I understand your question correctly, you're asking about the boundaries between, Python and other data models where you could potentially look at the typing data too?
So if you're coming back in and you have a large schema that is, maybe it's just REST objects, maybe it's this. After a while, you want to say, look, I've got a simple REST interface. I don't want to actually have every REST library out there redefine how it's going to check all the types. So do you see the standard syntax sort of moving into all of those libraries? And we see it for schema validations in some other languages, whatever people use for types.
So
are you eventually going to have one type language across all the languages, do you think?
Oh.
One thing that is maybe related to your question, so you can generate PYI files for things that are not actually Python. So for example, C extension modules. They're not Python, they're C code, but they have a Python API. So you can generate a PYI file for them or generate typing information for them, and type checkers can use that. There's an open source project called Cliff that tries to replace Swig as the new way of writing C extension modules, and that can generate PYI files. So it hooks nicely into type checkers, and you can do something very similar with protocol buffers.
So speaking of alternate users, there was this window that you mentioned during which there were annotations in the Python language, but there wasn't a specified use for it. Have you pondered or found any other usages of the syntax before you moved on to, okay, let's do typing?
Yes, we looked at this. Guido was pretty set on using annotations for typing from pretty much day one. He just hoped somebody else would pick it up and do it for him, and that didn't happen. So when we actually looked at the current situation, it sort of backfired in the sense that, like, at the very time when we were trying to standardize type annotations, people actually discovered that there's always been function annotations in Python 3 since 3.0. So they started releasing those libraries that do command line argument, parsing and sort of automatic, context setting for unit tests and whatnot. But most of those libraries have been only used by their authors. So we didn't really feel blocked by existence of some experimental projects. For a while we pondered actually supporting this very ugly mode of providing a dictionary inside the annotation, so the type key would have the type information, but other keys could have something else. But even for very simple types, that looked just so bad that we didn't even want to suggest this. Was rejected very early. So yeah, so for now, there is still support for alternative uses of this. You can either pretty much just say type ignore in a comment on the top of your file that says to the type checker, ignore this entire file because it's probably using annotations in a way where a type checker would not be happy with. And for a given function, you can also ignore type annotations by using a decorator that is in the typing module. But that's not an invitation for you to start using them today for a new library that has a different use, because that is going to be standardized at some point to the point where other uses are likely not going to work anymore. So pretty much that feature is set now.
Talking about how it backfired, I also feel that if we had written PEP 3107. Now, together with PEP 484, we probably would have done a few things differently, like not actually evaluating the annotation that are put into place. So right now, when you refer to a class that is declared after your type annotation, you have to put the annotation in quotes because it's getting evaluated right away and the class is not declared yet. So yeah, that's how it is.
Yeah, so with some other languages, like the typing is like, if it compiles, it almost works. But how much confidence can you have, and like, what are the upper bounds of the limitations in like a dynamic language with like this type checking?
I found in practice that in products I've been writing that use typing, it's a very good first check to, when I make a change, to first see that the types still match. If they do match, most likely my change was correct. Of course, I also run unit tests. It's not a complete guarantee because the type system is not completely safe, and you can have any types that are completely unsafe, but it's, in general, it is a very good help in making sure your code is correct.
So the concept you have to like sort of internalize when you think about this sort of like if it compiles then it works, and like, you know, except for Rust and maybe Haskell, like that's like typically not even true. Like so like in C and C++, like yes, good luck. Is that in Python we have gradual typing. Gradual typing means like when you just start out with your adventure to like type your first function, even like the uses of other functions inside your own file, inside that your own single typed functions are not going to be checked, right? Like the type checker is going to assume that anything that you're calling is okay because it has no types, so it means probably it just accepts anything and it returns anything. So the value that you're getting is going to sort of exponentially raise the better your coverage is. And when you're starting to talk about coverage, there's this other thing that you should keep high coverage of, and nobody does. So like you see where I'm going with this. It is very useful, but like so far at the actual code bases that I covered types with, it mostly prevents new bugs from being introduced by basically making the cycle of coding faster. But to like decrease the existing errors, like we haven't seen a clear correlation of this yet. So yeah, like it's gradual typing, like sort of realistically there was no other way to introduce this to Python. So the expectation is not quite as strong as with the statically compiled languages.
Yeah, if I could say one comment about that is that I actually tried it in my own personal projects at work, and I just tried it with one small functions, and the benefit of just being able to isolate it to specific subsets for the beginning is really helpful to start integrating like a CI system, right? And then slowly, when you have time, you can clean up some other technical debt. And yeah, I found it very beneficial that you don't have to apply it everywhere necessarily. Yeah. So there are also other tools, right, that do, instead of static type checking, they do runtime type checking. So for example, there's this tool called Enforce or TypeGuard. Any of you heard about that? And what do you think about it?
So we also played around with runtime type checking. And it's not completely straightforward, especially for deep types. When you type annotate something as a list of integers, and then somebody passes you a list, then all of a sudden you have to go through the entire list to verify, yes, that's all integers. There's ways around that, but there are certain performance implications associated with runtime type checking. And why would you want to check at runtime if you can check during compile time?
I mean, so I guess to answer your question of why you would check at runtime, for example, so I added more types to Zulip, which is an open source chat application, and particularly Django stubs, and I found about a dozen bugs. And one of them, it was an integer was being passed, or sorry, a string was being passed all the way down a bunch of functions, and at the end it was being wrapped in int, so that it worked at runtime, but throughout all of those functions, it was a lie that it was supposed to be an integer. So, so if you had runtime type checking, you would catch it way up where the first time you passed a string instead of an integer, instead of 7 functions down, and you have to go through the stack trace, and it can give you a bit better debugging experience.
Also, I imagine it's a lot slower, right, than what you're proposing, the techniques that you're proposing, right?
Right. So the current type checkers use, as I mentioned, sys.settrace, and they have the type checking code entirely in Python using inspect. The module that I started working on actually just last week is in C and uses Python C API. So and uses the frame evaluation API. So it should be at least an order of magnitude faster.
So the static analysis that we're doing is much more mature than the runtime type checkers that you have. Like the ones that I've been playing with, they always had the same problem that like our original runtime type collection had, which is that in Python everything is dynamic and you can redefine everything, including like getAttr and like other stuff like this, which means you cannot very safely, just like look at an object. If you're not careful, you're gonna have side effects just from doing that, right? And that's obviously terrible, right? Like you're changing the code's execution, and you are only supposed to like verify if the types match. So it's because of the performance implications and stuff like this, this is a bit of a more hairy project that it looks like.
And doesn't adding a compile step to the workflow, doesn't that go against like the philosophy of Python as a scripting language?
So it's not a compile step at this point, right? It's this is sort of like MyPI is used as a separate step in your continuous integration or with the integration with your editor or whatnot. It's sort of sidestepped. It's not really used for you to like deploy your code. What we found out internally at Facebook though is like, it would be really cool if we could just compile the thing, right? So like internally we do like package like everything that we're releasing to a single file, which pretty much like simplifies, your deployment. You don't have to play with virtual envs and, be afraid that the runtime is going to be slightly different or the versions are not going to match or whatnot. And once you're already doing that, like you could do like a lot of more things. Like for example, like remove the types from runtime so that they don't slow you down, and like other things where like, if you think about this, like inlining functions or whatever else, like is possible with, sort of modern C++ compilers or whatnot. Like a lot of this is perfectly usable, so like as a technique in Python, but we would never use it because we just don't have a transformation step yet. There's an OpenPEP 5.11 where Victor Stinner actually tries to introduce an API for this. It doesn't have anything to do with static typing. It's more of a, like bytecode transformation that happens in sort of in place when you're first executing your code. But I think it goes a long way, where we could do like performance optimizations on the code that we already have, because the current compilation step that we already have, the PYC files or PYO files, it's very, sort of primitive, right? It doesn't do much.
Yeah, and type checking is definitely not a compile step, because if any one of you is a PyCharm user, you're already using type hinting and type check, even though you don't explicitly specify types for your function. I mean, we run type hinting while you are writing your code, so it's not really a compile step. It's just, I don't know, a part of your editor. And I guess it applies to other plugins for, I don't know, for Vim and so on. So the best value from type checkers is when you see your potential typing errors while you are typing your code. And I don't know, even though it is really a nice thing to have on your CI server, I think that the most value from type checking in Python comes when you do this stuff locally while you are programming.
I mean, it is a compile step in the sense that you typically want to run something else or have to run something else before you actually deploy your program or run your program. You edit, and then you run the type checker, and then you run your program. But in a sense, we already had that because typically you want to run your tests before you run your Python program.
And I wonder, most organizations, how much of MyPy or PyType or other type of static type checkers, how much of the use of it, like how much do you disable? Like 70%, you keep like 70% or something similar to that?
Oh, so that's interesting, right? So like with gradual typing, like you could just go all the way like on your first day and enable all the like, you know, crazy options in MyPy that you can have. You're gonna receive 10,000 errors and you're never gonna look at it again, right? So like even your type checker configuration is sort of gradual in like what you're gonna enable like in time. At first, and this is something like a bit embarrassing like as well, where we actually keep a very strict configuration, but then we sort of strip some of the warnings like from MyPy's output on things that we know that are like not quite ready for people to see yet. Since like so far MyPy is very dynamically developed, like very like quickly iterated on, so it sort of makes sense to just keep the configuration like stable. But for example, the Flake8 MyPy plugin that is just running on your particular file, that has almost everything disabled because it's supposed to only be looking at your particular file and it's supposed to be fast as well, right? So like the biggest problem that MyPy currently faces really, like if you just start using it, you're gonna see the value, you're gonna be happy, but you're not gonna be happy about its performance, right? Like if you actually have like a pretty big project, you're gonna see runtime and like that basically just counts in minutes, right? So like on the Instagram code base, it takes like 4.5 minutes for it to complete, right? That's fine if it just runs on some like box in Virginia, like, you know, like it's like as a continuous integration step, but that would never work for something that you lint against like inside your editor, right?
So MyPy is actually looking to make a more relaxed mode for those who are just starting with typing. And so this would do things like look at collections and just infer any's for the types of the items in the collection. So you can have just, you know, list equals and then an empty list, which is normally reported as an error, and some other things which will make it easier to start using MyPy. We haven't gotten there yet, but we are looking forward to that.
I guess, how far down the rabbit hole do you anticipate this going as you get to more complex data types, ND arrays, NumPy arrays, pandas DataFrames? How do you type check those in the long run and have it be accurate?
So, and this is already a problem. Like some of the standard library functions are very like crazy in what they accept, and like some of the things have very complex rules on what they return. The simplest example is how like the built-in open, right, is parametric on the value of the string that you're giving it as a mode, right? Like it just returns something else, depends on when you're like RB or just doing R, right? So some of the types are very complex, but what I always think, and like that's sort of maybe like a personal opinion of one of the guys, is that the most important thing about typing is for it to be readable by humans, right? The type checking thing is nice to have. That's like cool, like, you know, to you to find additional bugs, but that always comes second. So if you have like a type that suddenly like, you know, takes 5 lines to even create, you just look at it like, I don't really think it's worth it. Like at this point, like the people that are afraid of it are like, you know, have a point, right? Like, you know, it just doesn't really look at, you know, like Python anymore. The one thing that I would just wanted to mention is currently PEP 484 doesn't really say that it doesn't support recursive types. They could be recursive. But in practice, we just simply don't have, you know, type checker that would support this. Maybe PyType does, I don't know. MyPy doesn't at this point. So like, in fact, if you just want to like type check JSON, you cannot, right? Like you have to sort of simplify your expectations at this point. And I think that's okay. It's gradual. Like, you know, it's mostly a way for you to put information that you would already type in your doc string. Like, you wouldn't really put 5 lines of like type documentation in your doc string about like one stupid argument that is optional anyway, right? So like, I wouldn't really worry about this, but like my rule of thumb would be like, just don't overdo it. It's not worth it.
Since you mentioned NumPy, so a lot of times, or sometimes you have, you know, a complex API or an API with complex types, and you're not really interested in type checking that, you know, API or library itself, but you want to verify the code that runs against that. And in that case, it might actually sometimes make sense to have, you know, a type declaration that is 5 lines long, because, you know, you're writing this once and then all your other code is being verified against that API. And that's often the way out to, you know, handwrite a PyI file that really nicely specifies your API, and then use that in order to verify the calls of that against that library.
Yeah, so like for NumPy or like a few others, you can look in Typeshed. Like some of the types are already hairy. Like the things on Star Library that I just mentioned, yes, they also generate quite a lot of like, you know, confusion sometimes for us, where we know that there's some edge case and now we have to support. Yeah, but that's sort of a orthogonal case. Like, you know, if you're just, you know, typing your own code, which is just a regular Python file, yeah, like I would be more lax. But yes, for PyI files, maybe makes sense, because normally people wouldn't look at it. Like, that's the typical type checking case here.
So
Typeshed definitely has some interesting corners. Like the definition of Itertools IZIP, I think, is 20 lines.
Yeah, so just going back to NumPy and Open, MyPI recently has added support for plugins such that you can change the types depending on what the inputs are, et cetera. So,
thank you very much. Unfortunately, we're out of time, but I really want to thank our panelists again. Thank you so much.